Welcome to Arsenal, where the weapons and war machines of military history come to life. Today, we explore the M104 Wolverine Heavy Assault Bridge, its role in modern armored gap crossing, and the engineers and armored crews who gave it its reputation. If you enjoy learning how technology, tactics, and human decisions come together in combat, you can find more articles, podcasts, and resources at trackpads.com.
The story begins in a dusty training area in Texas, where an armored column grinds to a halt. Ahead of the lead M1 Abrams, a deep anti-tank ditch cuts across the desert floor, wide enough to stop 70 tons of armor. The exercise clock is running, and the notional enemy is already repositioning while the tanks sit in a choke point. Commanders know that momentum is the one thing they can never get back.
From the middle of the column, a squat shape rumbles forward. From the hull down, it looks like an Abrams, but where the turret and main gun should be, a folded bridge rides along the roofline. The M104 Wolverine noses up to the lip of the ditch and drops a hydraulic spade into the dirt to anchor the hull. Inside, two combat engineers work under armor, communicating over the intercom and the company radio net. Arsenal is the Friday feature of Dispatch, U.S. Military History magazine.
With a hiss and a clatter, the aluminum Leguan bridge begins to move. The launcher lifts the folded sections, slides them forward, joins them, checks sensors, and drives the span outward until it reaches the far bank. Tank commanders behind the bridgelayer watch the obstacle, their watches, and the imagined threat of enemy artillery. In roughly 4 minutes, the bridge settles onto the far lip with a dull metallic thump. The Wolverine retracts its launcher, hauls up the spade, and lurches forward across its own bridge. Then the Abrams tanks roll after it, one after another, turning what had been a solid obstacle into a short pause.
The Wolverine existed because of a tactical frustration that hardened during the late Cold War. American heavy armor was becoming faster, heavier, and more demanding. The bridging vehicles that supported it were still built on the older M60 tank chassis and carried steel scissor bridges dating back to the 1960s. Those systems could still span streams, ditches, and narrow gaps, but they no longer matched the tempo or weight of modern armored warfare. In exercises, planners saw the same problem again and again. M1 Abrams and Bradley formations could surge across country, only to stack up at a riverline, canal, demolition crater, or anti-tank ditch. Older bridging vehicles lagged behind or operated near the edge of what they could safely carry. Tanks often had to cross one at a time at a cautious crawl, while commanders worried about bridge limits and the clock kept running. The bridge, meant to enable maneuver, became a brake on it. Sustainment made the problem worse. M60-based bridgelayers were aging, maintenance-intensive vehicles with shrinking parts support. Keeping them running demanded time in the motor pool that could not be spent rehearsing complex gap crossings. In an army increasingly focused on rapid maneuver and high-tempo operations, heavy formations were still depending on bridging tools designed for a different generation of war.
The answer seemed simple in concept. Put a modern bridge on an Abrams chassis, give it comparable speed and protection, and design a launcher that could emplace a long, heavy span quickly enough to keep armored task forces moving. That idea led to cooperation between American and European teams and to the use of the aluminum Leguan, rated for roughly 70-ton vehicles at combat speed. Mounted on an Abrams hull and optimized for under-armor launch and recovery, it became the vehicle the Army designated the M104 Wolverine. Its job was to turn obstacles back into mere features on a map.
Work on the heavy assault bridge concept moved through the 1980s, but shifting budgets and the end of the Cold War delayed decisions. Crossing vehicle had to match the Abrams in mobility and protection, keep its crew under armor, and throw a span long enough to defeat ditches and demolished bridges designed to stop heavy forces.
By the early 1990s, The Army had a clearer requirement. General Dynamics Land Systems partnered with the German firm behind the Leguan bridge family, offering a modified M1 hull with a horizontally launched aluminum bridge. The Army selected the layout in the mid-1990s and gave it the experimental designation M104 Wolverine. As the design matured, the chassis shifted to the M1A2 System Enhancement Program level, giving the Wolverine the digital backbone, power generation, and automotive performance of the frontline tank. Trials showed it could emplace a full bridge in minutes, recover it in under 10, and keep the crew protected throughout. The original production vision was much larger than what followed. Early concepts imagined several hundred Wolverines supporting heavy divisions in multiple theaters. In practice, doctrine shifted toward lighter and more expeditionary forces, while budget pressure reduced the fleet to only a few dozen vehicles. Those Wolverines went to select engineer units, where they demonstrated what fully modern armored bridging could do. In basic terms, the Wolverine was a United States armored vehicle-launched bridge based on the M1A2 tank chassis, operated by a two-person crew, carrying a roughly 26-meter Leguan bridge rated for 70-ton vehicles and able to lay or recover that span in minutes while keeping pace with Abrams formations. Over time, the Wolverine's advantages were weighed against its costs. Maintaining a specialized bridge launcher on an Abrams hull, complete with sophisticated hydraulics and electronics, was expensive and demanding. As the Army looked for a more affordable way to modernize its bridging fleet, attention shifted to the Joint Assault Bridge, another Abrams-based system designed to replace both the aging M60 Bridgelayers and the limited Wolverine fleet. The M104's production run ended quietly, but its development and field experience shaped the thinking behind its successor. Walk up to a Wolverine in a motor pool, and from the glacis plate down, it looks like an Abrams. It has the same broad hull, armored skirts, and purposeful stance on 6 road wheels per side. Above the hull, everything changes. Instead of a turret and gun, it carries Leguan bridge sections on a launch frame, nested like a folded ladder along the roofline. Behind the armor sit the same gas turbine engine and transmission used in the tank, giving the Bridgelayer the acceleration, road speed, and cross-country mobility needed to move with the armored columns it supports. What it lacks in firepower, it makes up for in mobility, protection, and the ability to keep the formation moving. Inside, the crew space is part tank and part specialized engineer vehicle. The driver sits in the familiar front left position. Behind and above him, the vehicle commander also serves as bridge operator, working at displays and controls connected to the hydraulic and electronic launch system. Both crew members can operate the bridge controls, and much of the launch sequence is automated. The crew selects the site, checks the geometry of the gap, anchors the vehicle, and supervises the system as it lifts, extends, locks, and places the bridge. Throughout the process, they remain protected inside the hull. Launching the bridge is a choreographed drill. The Wolverine drives to the near bank and drops its rear spade to lock the vehicle in place. Hydraulic actuators raise the folded bridge stack and slide it forward. The sections lock into a rigid span as they clear the hull. Unlike a scissor bridge, the Leguan bridge extends horizontally, keeping the vehicle's silhouette lower and easier to conceal behind terrain. As the far end reaches the opposite bank, the commander fine-tunes alignment through periscopes and cameras. Once the bridge is down, the launcher retracts, the spade comes up, and the Wolverine either crosses first or moves aside to let tanks and infantry fighting vehicles pass. The vehicle's subsystems all serve one purpose: getting heavy forces across obstacles without a long pause. Its communication suite links it to broader command and battle management networks. Its hydraulic and power systems are designed to move the bridge smoothly under difficult conditions, from dusty desert to muddy canal banks. Crew conditions remain cramped and noisy, like an Abrams, but the engineers are climate-controlled and protected, not exposed on top of a truck or launcher. In training, crews rehearse under time pressure, simulated enemy contact, and malfunction drills. In combat, the Wolverine becomes the quiet pivot point in a much louder fight.
Its real test came not in theory, but in Iraq. In late 2006, the 20th Engineer Battalion, one of the first units to receive the new heavy assault bridge, deployed with an armored brigade into Baghdad's dense urban sprawl. Their mission was to keep armored and mechanized forces moving across canals, highway cuts, and demolition craters in a city where every choke point could hide an improvised explosive device or ambush team. Older M60-based bridgelayers had already served in earlier operations, but Abrams and Bradley formations needed bridging that matched their weight and tempo.
A typical Wolverine mission often began in darkness. Route clearance teams moved ahead, searching for pressure plates, command wires, and other threats near a suspected obstacle. Tanks and Bradleys took overwatch positions, covering likely firing points. Once engineers judged the site clear enough, the M104 rolled forward, its turbine whine familiar to everyone on the net. The commander placed the hull at an irrigation canal, road cut, or blown overpass, dropped the spade, and began the launch sequence from behind armor. Within minutes, the Leguan bridge slid across water or broken concrete, creating a 26-meter span strong enough for a 70-ton Abrams at combat speed.
These crossings rarely made headlines, but they shaped the rhythm of operations. In Baghdad and along other Iraqi routes, Wolverines turned canals and highway cuts from stop signs into brief pauses. Crossings that might have taken far longer with improvised solutions could be reduced to a handful of minutes with a purpose-built bridge. Reports from the period describe Wolverines supporting route clearance and obstacle breaching missions as armored units tried to avoid predictable routes and maintain pressure on insurgent networks. Commanders learned to fold the vehicle into battle drills, secure the near and far banks, launch under armor, and push combat vehicles across before the enemy could react.
Even when the Wolverine was not under direct fire, the stress on its crews was real. Every minute sitting beside a canal or on a skyline exposed the vehicle to possible mortar fire, buried explosives, or missed threats. Training at the National Training Center and other ranges reflected that danger. Crews practiced bridge launches under simulated artillery, misalignment problems, and mechanical pressure. Photographs from Fort Irwin and later Fort Johnson show Wolverines extending their bridges over dusty ditches under observer control, rehearsing the same actions used in Iraq. The combat lesson was clear. An Abrams speed fully armored bridgelayer could erase heavy obstacles without giving the enemy a long window to respond.
For engineers who used it, the Wolverine's greatest strength was that it finally put armored bridging on the same footing as the tanks it supported. Built on the M1A2 System Enhancement Program hull, it shared much of the Abrams tank's mobility, protection, and logistics trail. It could maneuver with heavy brigades instead of lagging behind them. Its 26-meter bridge could carry 70-ton vehicles at around 16 kilometers per hour, letting Abrams crews cross at a controlled roll rather than inch forward on older spans. Its launch and recovery cycle kept engineers and the rest of the column protected and moving.
Automation was another advantage. Once the crew confirmed the site and anchored the hull, the computer handled much of the sequence. That reduced crew exposure and cut down on manual work that once placed engineers in dangerous positions. The communications system tied the vehicle into brigade and battalion networks, allowing crossing plans to be coordinated like any other tactical action. In theory, and often in practice, the Wolverine turned gap crossing from a separate engineering project into a timed maneuver woven directly into the fight.
The weaknesses were tied less to battlefield performance than to cost, complexity, and scarcity. The Army had once envisioned hundreds of Wolverines replacing older bridge layers. Instead, production stopped after roughly 44 vehicles. Maintaining a highly specialized Abrams-based launcher with advanced hydraulics and electronics proved demanding. Budget cuts and a shift toward lighter formations made it harder to justify a large fleet of heavy, fuel-hungry bridging vehicles. Some commanders worried about relying on a capability that existed in such small numbers, knowing that a single mechanical failure or combat loss could remove the only Wolverine available to a task force.
From an enemy's perspective, the Wolverine reduced one of the traditional ways to slow an armored column. Blown bridges, anti-tank ditches, canals, and road cuts had long been reliable obstacles. With an M104 in the formation, those barriers became temporary problems rather than fixed walls. Opponents adapted by attacking approaches to crossing sites with improvised explosives and indirect fire, or by targeting engineers and dismounted security teams. In that sense, the Wolverine did its job well enough to force enemies to change how they tried to interfere with American movement. Compared with the M60 armored vehicle launched bridge it was meant to replace, the Wolverine offered better protection, better mobility, and a longer, stronger bridge, but at a much higher financial and logistical price. The joint assault bridge that followed took a different approach. It also used an Abrams hull, but carried a shorter 18.3-meter scissor bridge that could deploy in about 3 minutes. It gave up some span length for a simpler, more sustainable launcher and a program sized to replace both the old M60 Bridgelayers and the small Wolverine fleet. The M104 showed what was possible. The joint assault bridge reflected what the Army believed it could field across the force.
The Wolverine never developed into a broad family of variants. Its core idea remained consistent, an Abrams-based chassis carrying a Leguan bridge on a horizontal launcher. Development focused on bridge sections, controls, hydraulics, and integration with the M1A2 electronics rather than on new subtypes or export models. The vehicle remained a niche tool for the United States heavy engineer units, which helped keep it rare even within the Army.
The real evolution happened around it. The Leguan bridge system continued as a broader family on other chassis in European service, while the experience of mounting it on an Abrams hull taught designers lessons about weight distribution, hydraulic power, automation, and crew workload. Those lessons fed directly into the joint assault bridge. At the doctrinal level, the Wolverine helped cement the idea that heavy brigades needed organic, Abrams-speed bridging as part of their standard toolkit. Gap crossings were no longer awkward pauses. They became deliberate, rehearsed actions built into the brigade's battle rhythm.
Today, the Wolverine occupies an interesting place in Army history. It is modern enough that some examples still appear in training and evaluation roles, yet rare enough that many soldiers have never seen one outside a photograph. Heavy brigade engineer units at training centers have used Wolverines in obstacle breach scenarios, rehearsing the under-armor bridge launches that once supported operations in Iraq. Maintenance and training images from Fort Irwin and Fort Johnson show the vehicles still being kept in working order, even as the joint assault bridge gradually replaces them in frontline units.
The M104's legacy lives on in later Abrams-based engineering vehicles, and in the expectation that armored bridgelayers should share speed, protection, and support systems with the tanks they accompany. It also reinforced the idea that bridge launches should be automated, repeatable, and possible without exposing engineers to direct fire. As Wolverines rotate into storage, retirement, or museum collections, they will likely stand beside the M60-based bridgelayers they were built to replace, marking a transition from Cold War bridging to modern armored mobility. Whatever replaces it in metal, the Wolverine's core idea endures. In modern war, the force that can cross the gap first often decides how the rest of the battle will be fought.